번째 세션은 D-Wave의 스위치 후쿠다님께서 Quantum Optimization for Mobile Network Performance라는 주제로 온라인 발표를 해주시겠습니다. May I have your attention, please? We will now begin the second session of the Yonsei Quantum Week 2025 Quantum Industry Session. In this session, Shuichi Fukuda from D-Wave will give an online presentation on the topic Quantum Optimization for Mobile Network Performance. Please welcome.
네, 안녕하세요. 저는 슈이치 후쿠다입니다. I'm from NTT Docomo. I'm very happy to here to present a case study on quantum computing at Yonsei University. NTT Docomo is a mobile operator in Japan, and we are working with KT and SKT and exchanging ideas and opinion on telecom technologies. In recent years, with the advantage of generative AI, the development speed of IT services has become very fast, and the field of quantum optimization can't be no exception. I strongly believe that the telecom operator can provide the various fields, various domains based on the customer data with their field. And by processing large number of data, we can optimize the use of the data. What I want to say is that company with wide various of data have the potential to make a good plan and realize many optimization ideas. Today, we will present a case study of quantum optimization in telecom field at NTT Docomo. So, okay. Can you see my slide? Yes. Okay. Let's start. The title is Developing a Quantum Computing Platform to Optimize the Services. First, this is a mechanism for determining cell phone coverage areas. Mobile operators set up the base station throughout the country to connect a terminal everywhere, and each area divided and covered. This is a terminal, and this is a base station. The terminal registers the location when it's moved across an area named TL list, and a different TL list number assigned to each area. The location registration area is divided to narrow. Many location registration process will occur. It leads to a large load on the network. So NTT Docomo developed the efficiency division method, the optimization. This is the overview of tracking area optimization. When a terminal receives an incoming call after moving within TL list, the terminal can determine its current location by sending a paging signal to a group of base stations. So it's called TL list, TA, which is a smaller area than TL list. Left figure is an example of paging signal to grasp current terminal locations. First, current central unit send a paging signal to last connected base station, and terminal response it. The central unit can resolve the current location, but the terminal moved. Central unit has to send the paging signal to tracking areas. So that in right figure shows the concept of TA optimization. The illustration shows the TA groups, this divided with terminal moves in base station network. The arrows means the amount of terminal moves. Oh, by the way, how tracking area is determined in general? For example, in manually, one common method of determining the TA is to look at the map and determine the human eyes that maps road and highway and railroads will be in same TAs. So let's try to set the TA to optimize the number of paging signal by using two TAs. You can find the main flow with the red line, and also you can see the city area in orange areas. Identify major road and the urban area on the map. The general setup procedure is listed in left and right. First step, identifies the major road and urban area on the map. The next step is to divide the area considering with located major traffic lines in same TA. And final step, assign to the same TA code to base station belonging with the TA area. I designed TA pattern with A. How is this? Main flow and most cities are placed in same TA, and it seems good, but this is the next pattern B. The main flow across the TA border twice, but if the population in the blue area is large, the overall amount of paging signal will be less because its paging transmission area is smaller. So it is not possible to accurately determine the number of paging signal. So the map can take into account the flow of people on Main Street, but it is difficult to take roads, but the branch off from each others. The map cannot capture the area where the terminal movement is complex, such as underground area around the station and buildings. This is the flow of TA optimization. Our TA optimization uses the formula to estimate the paging signals based on the device movement data between base stations. The data is converted from the device control log. We also develop a map visualization tools to display the TA allocations and optimization results. Finally, the estimated reduction in paging signal is submitted to the branch office of our network. Since TA optimization is performed only one few times in a year, there is no need for real-time optimization. But the number of combination increase with the number of base station and TAs. So a single solve can take a numerous amount of time. Once the TA optimization is done, the operator staff at the branch office will review the optimization result and make correction. Therefore, the time required for each task should be short. Classical computers struggle to solve the large combinational optimization problem with the time increase exponential with the problem scale. For example, quantum annealing can find a good solution to those problems in a fixed time. This is an example of the TA problem. It takes so long time. This is also we developed a tool to visualize TA allocation. Each point presents a base station. This one is the base station, and the car is TA. The line means the amount of movement. This visualization tool helps to ensure the TA groups is for a measure load. This is maybe this is a city, and this is a tunnel like thing. And yes, this is a result of trial in actual network. We tested our quantum annealing results in actual network. The result shows 15% of reduction in paging signal. It's improving network efficiency and communication quality. The graph highlights the decrease in both maximum and average paging signal after the trial started. We have developed a quantum computing platform to optimize the various aspects of services. The platform integrates for high precision and low cost efficiency optimization calculation. It connects to our customer data with quantum computing platform. It allows us to leverage quantum annealing. The hybrid approach enables us to track complex optimization problems with various scales and accuracy requirements. We believe that our quantum computing platform has the potential to realize various fields, not just telecommunication. Beyond our own industry, we see potential in areas like construction, where it could optimize equipment and potential planning. And we also expected about the future of quantum computing and its potential to drive innovation across industry. That's all. Thank you for listening.
Is there anything you can talk about the future innovation areas on the last slide that you were showing?
We are focused on the telecom field. Oh, sorry. This is earlier, and next is finance, because I'm belonging to finance area, so I want to try to optimize the portfolio optimization and other problem, maybe.
Okay, thank you.
Yes, thank you for your question.
one
Okay.
if one more question. Can you talk about what the process was for optimizing the TA lists before implementing D-Wave? You talked about the map method. Was that the main method, or did you have some other, maybe an algorithm that ran on classical computers using a small number of TA areas, or was it completely manual?
The first time in NTT Docomo, the branch office using the map, and they determine the TA area. But next step, we use the algorithm to determine the area. It is not using the quantum computing. But the problem was the algorithm can't solve the TA problem because it uses classical computers. So in our approach, we use the quantum computing, and it makes a good result with high efficiency and less time. Yes.
Okay, so you tried previously, before implementing the quantum solution, you tried a classical solution, but it was unable to give you good results due to the large problem size. Okay, understood. Thank you.
Yes.
Someone asked a question on YouTube. Thank you for your talk. In your case, you applied 270 base station. Are you going to increase more base stations? And second question is, what's your next plan?
Yes, thank you for questions. This is an example of the TA problem. The number of base station and TA becoming big larger. So the problem is becoming very large problem. So we have to use the quantum annealing. And second question, next step is next step is we are trying how can I say, we're trying to determine the TA. The next step is, I think, TA list. The problem is not TA, not increasing TA for TA list. It becomes a more larger problem. So we have to make wait. We have to develop this middle software, and you have to make a Hamiltonian for optimization. It means a formula of how can I say? It's formula to minimize the pacing and other network indexes. Yes, that's all.